Okay, so just be aware that an exponential function, we're gonna graph an exponential function either at the end of next class period or the last class period. But an exponential function is a function where the variable is in the exponent. An exponential function is a function where the variable is in the exponent. So it looks something like this. Now don't let that throw you off. It's very simple to deal with. But next class period we're gonna graph this exponential function. It looks like this. 2 to the x. Notice the difference between this one and this one. See, this right here that I'm pointing to, where's the variable? The base. The exponent's a number, right?
Mm-hmm.
Here, your base is a number, and your exponent is a what? Variable. This right here is called a quadratic function. See the x squared? That's quadratic. This here, though, is called what kind of function? Exponential. So we'll talk more about exponential functions next time. But the point here is that in an exponential function, the variable is located where? In the exponent. Okay? Variable is located in the exponent, hence exponential function. And the graph looks different than a quadratic. You'll see what it looks like. So remember a while ago with a rational function we found a horizontal asymptote? Exponential functions have a horizontal asymptote. So you're going to see some similarities there. Exponential functions have a horizontal asymptote. Doesn't have a vertical though, and you'll see why. But it will always have a horizontal. Now here's what you have to do though for your test that's coming up. And listen carefully. So you have to solve an exponential equation. Now here's an example of an exponential equation, and we're going to come back and solve it in a little while. But here's what you have to be able to do. On your test, you have to be able to do something like this. Solve 4 to the x plus 1 equal 8 to the 2x minus 3. You have to be able to solve that. Isn't that hard? Not hard at all. Because there's something you can do to this. There's something about the bases. See what's the base here?
4.
And what's the base here? 8. There's a relationship between those two bases in terms of what we need. Okay? Now listen carefully. Solve this. Suppose I have 5 to the x power equals 5 to the 7th power. If 5 to the x equals 5 to the 7th, and remember when I say solve, I'm asking you to solve for the variable x. What must x be in order for those two sides to be equal to each other?
7.
7. X must be 7. So if 5 to the x equals 5 to the 7, then in order for those two sides to be equal to each other, x must equal what? 7. There's your solution. X is 7. Now that was simple because in order to do that, what must be true about the bases? They have to be the same. So if you can get the bases to be the same, then that's an easy thing to deal with. So the rule is basically this. If you have b to the a power equals b to the c power, then what must be true? Then a must equal what? C. A must equal c. Your exponents must be equal to each other. Okay? All right, so that was number 1. Let's look at number 2. Number 2. Suppose I had this. 4 to the x plus 3 equals 4 to the 2x minus 1. I got to find out what x is. 4 to the x plus 3 equals 4 to the 2x minus 1. So what are you going to do? X plus 3 must equal what? 2x minus 1. Why is it that I can just set the exponents equal to each other? Because the bases are the same. So x plus 3 must equal 2x minus 1. Now what kind of equation did I just write? A linear. So I'm going to subtract x from both sides. So I get 3 equals x minus 1. And then finally I'm going to do what? Add 1. So what's x? 4. So I found my solution. My solution must be 4. And you can check it. Look, what's 4 plus 3? 7. What's 2 times 3? I'm sorry, what's 2 times 4? And what's 8 minus 1? 7. Okay? Number 3. Number 3. Now remember, the first two are easy because the bases were what? The same. All right, let's number 3 now. Number 3. Suppose I had 3 to the 4x plus 1 equals 9. 3 to the 4x plus 1 equals 9. You got to get the base to be the same. So which one do you think you would rewrite? The 9, because what do you notice about 9? It's what? No. 3 to the second power. Because I can write 9 with what base? 3. It's because I'm trying to get the base to be the same, right? The bases are not the same. That base is a 9, that's a 3. But I know that 9 I can write as 3 squared. And now I can solve. So now I said the exponents equal to each other. So I get 4x plus 1 must equal what? 2. And notice I end up with what kind of equation? Linear. So subtract 1, I get 4x equal 1. So what's x? 1/4. That's your solution. And it kind of makes sense because watch. Look, to check it. What's 4 times a 4th? What's 4 times 1/4? 1. What's 1 plus 1? 2. What's 3 squared? 9. That's what you wanted. Number 4. Listen carefully to this. 2 to the 3x minus 1 equals 4 to the x. 2 to the 3x minus 1 equals 4 to the x. Are the bases the same? No. What kind of equation is this, though? Exponential. All you know right now is to try and get the base to be the same. That's all you know. That's all you know. I got to try to get the base to be the same. Later on in the last class period, you're going to see that there are times when you cannot get the base to be the same, so you got to do something else. But for us right now, we can get the bases to be the same. So I want you to look at this. What's this base here? What's this base here? 4. Is there any way you can rewrite 2 and 4 to have that same base? 4 is what? 2 to the second. Very good. This is 2. 4, I know, is 2 to the second. So watch carefully, though, how you're going to do this. Listen carefully. So you get 2 to the 3x minus 1 equals, so you see this thing I have circled? I've got to rewrite this as 2 to what power? The second. But remember, that's all being raised to what power, though? X. So make sure you do it like this. You learned in a previous course that a power raised to a power, what do you do to those powers? You multiply. So this becomes 2 to the 3x minus 1 equals 2 to what power? 2x. So now the bases are the same. So what do? Set them equal to each other. Set the exponents equal to each other. So 3x minus 1 must equal 2x. So I'm going to subtract 2x from both sides. So I get x minus 1 equals 0. So x is 1. So there's your solution. X is 1. Okay? Watch at this one. Number 5. The more you do, the better you get at it. These are the easy kinds. Number 5. Listen carefully. Number 5. Suppose I had this. Suppose I had. Now, from 5 on up is what you're going to need to be able to do. Okay? I think you have enough here to be able to get to number 5. So watch carefully. 9 to the 2x minus 1 equals 3 to the 5x. Okay. Are the bases the same? No, but can I? Yes. Or do you have to rewrite both of them, or do you just need to rewrite one of them? Just one in this case. Which one? No, not the 9 is what you have to rewrite. 9 is what? 3 squared. So they become 3 squared. All raised to what power, though? 2x minus 1 equals 3 to the 5x. Now, remember, you have power raised to power, so you got to be careful. 2x minus 1 has to be multiplied by 2. So that's 3 to the what? Now, I'm going to see if you get careful. 4x, that's true. What else? Minus 2, very good. Remember, everything up here has been multiplied by this 2. Equals 3 to the 5x. Now the base is the same. So 4x minus 2 must equal what? 5x. Subtract 4x from both sides. What's x equal to? Negative 2. There's your solution. Okay? All right, let's see if we can do number 6. Number 6. Okay, number 6. All right, listen carefully. All right. 8 to the x plus 3 equals 16 to the 2x minus 1. Now, if you can do number 6, I think you'll be okay. Are the bases the same? No. What are the bases, though? They're what? 8 and 16. Okay, now, think about what base can you use so they're the same so that we can rewrite 8 and 16. 4, okay, let's talk about 4. Someone said 4. 4 is not quite correct. Let's talk about it, though. I do agree that 16 is 4 to the second. But 8 is 4 to what power? There isn't a whole number. So 4 is not going to be your base that you're going to use. 2. Because I want you to think about it, guys. 8 is 2 to what power? The third. And 16 is 2 to what power? 4. 4. You got to think about that. So if you got just on the side, kind of rewrite like this and go ahead and do that. So 8 is 2 to what power? Third. 16 is 2 to what power? 4. So now I'm going to rewrite 8 as 2 to the third, all raised to what power? X plus 3 equal 2 to the fourth, all raised to what power? 2x minus 1. Okay? So that's 2. Now go ahead and multiply this out. That's 2 to what power?
3x
Plus 9, good. Equals 2, and multiply this out.
8x minus 4.
Yeah, now I said these equal to each other. So 3x plus 9 must equal what? Yeah, so I have this linear equation, so I just solve for x. So 9 equals, what's that, 5x minus 4? Add 4 to both sides. I get 5x equal 13. So what's x? 13 over 5. Okay? All right, let's do one more. Number 7. Watch. Okay, suppose I had 9 to the 2x minus 1 equals 27 to the 5x plus 2. The biggest thing is trying to get the base to be the same. Okay? You have 9 and 27. What base do you think you may want to use? 3. Okay, 3. Because 9 is 3 to what power? Second, and 27 is 3 to what power? No, third. Yeah, I agree. 3 times 9 is 27. It's all right. It's late. And so 9, I'm going to write as 3 to the second, all raised what power? And then 27, write as 3 to the third, all raised what power? 5x plus 2. Now that was the more difficult part, was trying to get the common base. Now let's multiply this out. That's 3 to what power? Power is power, multiply, so that would be 4x. What else? Minus 2. Equal, and then power is to power, multiply that as 3 to what power? 15x plus 2 or plus 6? Plus 6. One more thing you got to do that's major, and that's noticing that the base is the same, so then the exponents have to be what? Equal. So 4x minus 2 must equal 15x plus 6. That's linear now. Subtract 4x. I got negative 2 equals 11x plus 6. Subtract 6. I got 11x equal negative 8. So what's your solution? Negative 8 over 11. You just have one, but it'll be like 5 or, it'll be like 6 or 7. So 6 or 7 you need to focus on. Okay? All right, so let's listen to this. So to help you for that test. So the rest of the test is oh, look, it's on your study guide. You know how to do composition, right? That's what you turn in today. Y'all can do that. All right. So this is all the new stuff right here. The rest, what I would do is look at the old test and just look at the worksheets. Now listen to this. You had this one on test 1 and test 2, I think. That's where you get to solve a rational equation. Remember, you had to find the restrictions. If you go back, you see what I'm talking about. I didn't ask it on test 3, but I'm going to ask it on test 4. So make sure you look at test 1 also. I think it's on test 1. It is on test 1, but I'm not sure about test 2. Test 2, I'm not sure. Okay? Now, here's what I want you to do to help you for your test. Listen carefully. All I'm asking here is